Hello, good morning everyone. Myself Professor Praveen Dubey, delivering a lecture on chapter that is the mechanical energy based system, which is a come under the subject non-conventional machining processes. In last lecture, we have focused on abrasive jet machining. In mechanical energy based system, just we discussed before that, it consists of four processes: abrasive jet machining, abrasive jet machining, water jet machining, abrasive water jet machining, and ultrasonic machining. In last lecture, we have discussed on abrasive jet machining. Now, in today's lecture, we will discuss or focus on water jet machining and abrasive water jet machining. Now, see one by one. Water jet machining is one of the mechanical energy based system where you can use the high pressure water jet in order to remove the material from the workpiece by the action of mechanical erosion. See here, the water jet machining is a mechanical energy based non-traditional machining process used to cut and machine soft and non-metallic material. It involves the use of high velocity water jet to smoothly cut a soft workpiece. It is similar to the abrasive jet machining. In water jet machining, we are only removing the abrasive which are used in abrasive jet machining. Instead of a gas, we are using fluid, that is the water, as a working medium. And this water jet machining, it is mainly used to cut the soft and non-metallic materials by using the high velocity of the water jet. This is related to the water jet machining. Now, what is the working principle of water jet machining? See this diagram. This will be the workpiece. This will be the source of high pressure water. This will be the flow control valve, and this is the pipe. Those are connecting, and this will be the nozzle, and the distance between the nozzle outlet and the workpiece is called by stand-off distance, right? And at the outlet of the nozzle, you are getting the water jet, which is having a very high pressure. And by using this high pressure water jet, we are cutting the material, or we are removing the material from the workpiece, right? In a water jet machining, the high velocity water jet is allowed to strike or impinge on a given workpiece, and the velocity of that water jet is up to 900 meters per second. During this process, the kinetic energy of high velocity water jet is converted into pressure energy, which will induce a stress on the workpiece. When this induced stress is high enough, the unwanted particles of the workpiece are automatically removed by the action of erosion. This will be the working principle of the water jet machine. Now see the equipment used and setup of the water jet machine. It mainly consists of 7 parts: a reservoir, hydraulic pump, intensifier, accumulator, control valve, water jet nozzle, and flow regulator. Now this will be the reservoir. We may say this will be the reservoir. From this we are supplying the water. This water is passed to the hydraulic pump. It will increase the pressure of the water. Then this water is passed to this accumulator, where it will be stored, and up to certain extent its pressure is again increased, and at last that water is passed to the intensifier. Intensifier is multiplyly increasing the pressure on water, and that high pressure water is then passed to this nozzle through this flow regulator valve or control valve. When this high pressure water is coming to the nozzle, and when it is passing through the nozzle, the pressure energy of water is converted into kinetic energy, and we are getting the high velocity water jet, and that will be impinging on this workpiece, and the velocity of the water jet is nearer to 500 meter per second. That will be very much in order to remove the material or to cut the workpiece by using the high velocity water jet. This is the setup of the water jet machining: intensifier, hydraulic pump, accumulator. Then these are the control valves. This will be the nozzle, which is having material supply, and at the outlet of the nozzle you are getting high velocity water. Then there are certain process parameters. Those are affecting the performance of the water jet machine. Stand-up distance. What is stand-up distance? Stand-up distance is the distance between nozzle and the workpiece. As we have to maintain certain 1 to 2 mm stand-up distance between nozzle outlet and the workpiece. If you are goes on increasing stand-up distance, it will reduce the material. Fluid pressure means how much pressure you have to build on a water. That is very important. Up to 400 bar, you have 4000 bar, you may apply the pressure on a water. You have to increase the pressure of the water as high much as possible, up to 5000 bar. Then only it will able to remove the material from the workpiece. The transfer speed or feed rate, it also affects the material remove rate by using the water jet machining process. Jet of the fluid, nozzle diameter, these are the another parameter. Those are affecting the performance of the water jet machining. The different parameters those are affecting the performance of the water jet machining are stand-up distance, fluid pressure, feed rate or transfer rate, jet fluid, nozzle of the diameter. As far as possible, the diameter of the nozzle it should be a very small in order to achieve the high velocity water jet. Now, what are the advantages of this water jet machining? This is the very fast process as compared to the abrasive jet machining. It prevents formation of the heat affected zone on the workpiece. It automatically cleans the surface of the workpiece. It gives the excellent precision. The tolerance up to 0.005 can be achieved by using the water jet machining. It does not produce any hazardous gas, or we may call it is an eco-friendly process. Now, what are the disadvantages of this process? This water jet machining process is only applicable for the soft materials. A very thick materials cannot be machined easily by using the water jet machining. Means we can machine a very thin materials. Initial investment is high and it will be not suitable for the mass production. These are the advantages and disadvantages of the water jet machining. Now, in last, we have to study the application where this water jet machining is to be used. Mainly, this water jet machining is used or useful for cutting the material. Those are porous, fibrous, granular or soft, as like corrugated board, rubber, granite, plywood, glass, aluminium. Whenever you have to machine or cut this material, you go for the water jet machine. To cut the wood, ceramic, composite, leather, wire stripping, foam, you may use the water jet machine. In aerospace applications or any other similar industries, cutting of the asbestos is done by using the abrasive jet machining in order to minimize airborne dust in the atmosphere. It also used to cut the fiberglass and polyethylene automotive parts. These are the certain applications of the abrasive jet machining process. Are you understood the water jet machining process? These are the certain applications of the water jet machining, not abrasive. So in this way, this water jet machining process, how it works, what are the various parameters, what are the equipments used, and its advantages, disadvantages, and its application we have studied in this slide. Now next slide, it is related with the combination of this abrasive jet machining and water jet machining. That is called as the abrasive water jet machining process. Now what is the abrasive jet water jet machining process? The abrasive water jet machining, it will combine the abrasive jet machining with the water jet machining in order to create the unique process which will overcome their individual limitations, and it will help to enhance the machining ability of the water jet machining for the cutting purpose, drilling purpose, or general cleaning of hard and strong material. We go for the abrasive water jet machining. It induces material removal by the action of the erosion of high velocity abrasive and water jet, which is injected from a small diameter nozzle on a workpiece in such a way that the particle velocity is virtually reduced to zero after striking on the surface of the workpiece. This is the brief introduction related to the abrasive water jet machining. In short, this abrasive water jet machining, it will take advantages of abrasive jet machining and water jet machining and overcome their individual limitations, where the material is to be removed by the high velocity abrasive water jet, which will be impinging on the surface of the workpiece, where the velocity of abrasive particles it will reduce to zero after striking on the surface of the workpiece. Now, what is the working principle of this abrasive water jet machining? In abrasive water jet machining, if you see in diagram, this will be the source from high pressure water is coming to this mixing chamber, and from the another source the abrasive particles are coming. This high pressure water jet and abrasive particles both are mixing in this mixing chamber, and at the outlet of this nozzle we are getting high velocity abrasive water jet. Abrasive water jet machining works on a principle that a water jet and a stream of abrasive, it will be coming from two different directions. From this high pressure water is coming, and from this abrasive particles are coming, and both are mixed and passes through the abrasive jet nozzle. This high pressure water and abrasive, those are mixing in this mixing chamber, and these are coming out from the mixing tube as a high pressure water jet. Here, a part of the momentum of water jet is transferred to the abrasive. Whatever the momentum that will be having with the high pressure water jet, it will be transferred to the abrasive. As a result, the velocity of the abrasive, it will rises rapidly. Thus, high velocity stream of the mixture of abrasive and water, it will impinges on a workpiece that will remove the material from the workpiece. The material removal may occur due to erosion, shear failure under rapidly changing localized stress state. Means whatever the material is to be removed from the workpiece, it is because of a mechanical action, that is the erosion action, or it may be the shear or failure under rapidly changing localized stress state. This will be the working principle of a abrasive jet machining. Now, which are the equipment setup we have used for the abrasive water jet machining? In abrasive water jet machining, there will be pumping system, abrasive feed system, abrasive jet nozzle, and catcher is there. This is the water treatment plant from where we are supplying the water to the pump. It will increase the pressure of the water up to 400 megapascal. This high pressure water, it will be passed to this mixing chamber, where the abrasive supply hooper is there, From this hooper, abrasive particles are also supplied to this mixing chamber, and the high pressure water and abrasive particles, those are mixing in a mixing chamber, and you at the outlet of the nozzle we are getting abrasive water jet, which is having a very high velocity, and this abrasive water jet, it is coming from the abrasive jet nozzle. This high velocity abrasive water jet, it will impinges or impact on the surface of the water, and it will help to remove the material or cut the material. After use of this high velocity water jet, it is passing in a catcher, where its velocity or momentum it will be reduced by using the water. So this is the diagram or equipment setup or experimental setup of the abrasive water jet machine. This water treatment plant and pump, it will be a pumping system. This is the abrasive feed system. This is the abrasive jet nozzle, and this will be the catcher. In this process, we may have a movement for the abrasive nozzle, or you may have a movement. You may have your movement to the workpiece, depending upon the situation or the requirement of the process during the operation. Now these are the diagrams which shows the which kind of the nozzles we are using in an abrasive water jet machine. These are the certain diagram of the catchers. There are three types of the catcher: water basin, steel or tungsten carbide ceramic ball, or catcher plates. These are the certain structure or formats of the catcher, where water is filled in a basin, where ceramic wall is to be present in a basin, or certain catcher plates, in order to reduce the momentum or velocity of the water jet after cutting operation or after use. Then we will discuss the different processing or controlling parameter in an abrasive water jet machine. There are mainly 4 controlling parameters. Those are have an impact on performance of a abrasive water jet machine. First one, that is a hydraulic parameter. Second one, that is a cutting parameter. Third one, that is the abrasive related parameter, and fourth one, that is related to the mixing parameter. If you are considering the hydraulic parameter, how much water jet pressure you have required, how much flow rate it is required, how much nozzle diameter is required, they will have an impact on a process of the abrasive water jet. In cutting parameters, you have to think about the feed rate, standoff distance, number of passes, angle of impingement, what are the properties of the material which is to be used to cutting. And in abrasive related parameters, you have to study what are the different types of the abrasive particles, what size and shape you have to select, and what it should be the mass flow rate of the abrasive particles. In mixing parameters, you may think about the method of supplying the abrasive, what is the condition of the abrasive, and what will be the dimensions of the abrasive. These are the certain process parameters, those are having the impact on a process of a abrasive jet machine. The mechanism of metal removal rate, it will be carried out in abrasive jet machine, where certain process parameters, as we have seen in last slide, that is what are the different process parameter and what will be its range, that will be given over here. The orifice, its material, it may be a sapphire. Its diameter, it may vary between 0.1 to 0.3 mm. The focusing tube, its diameter is a tungsten carbide, and its dimension is a 0.8 to 2.4 mm. The pressure, it will be ranging between 2500 to 4000 bar. The size of the abrasive, it will be a 125 to 60 grit, and the flow of the abrasive particles, it will be a 0.1 to 1 kg per minute, and you may have keep a stand-up distance in between 1 to 2 mm. The angle of impingement, it will be in between 60 degree to 90 degree, and the transfer speed, it may vary between 100 mm per minute to 5 meter per minute, with the depth of cut 1 mm to 250 mm. This is the formula by which we can calculate the material remove rate of the abrasive water jet machining, where U is the certain constant of the material, CD is the coefficient discharge of orifice, D0 is the orifice diameter, PW is the pressure of the water, and rho W is the density of the water. The material remove rate in abrasive jet machining, it is generally governed by the curve. Curve is nothing but the a slot which is formed by the machining of the abrasive jet machining. The top of the curve is denoted by BT and the bottom of the curve it is denoted by BB. This will be the top, this will be the BB. It will be obtained by using the standard of distance between 1 to 5 mm. Now what are the advantages? Advantages of this abrasive water jet machining. It is a have a acceptance as a standard tool for cutting a different material in different industries. Employ for the decommissioning of nuclear facilities. The curve slot width of the in a range of 0.75 to 2.25 mm. Roughness of the cut surface varies with machine depth and abrasive water jet cutting parameters. These are the certain advantages of the abrasive water jet machining. Where this abrasive water jet machining is to be utilized? It is used to cut the wide range of materials which may include metals and non-metals. It is used to machine the sandwich honeycomb structural material currently used in aerospace industries. One of the most common application of abrasive water jet cutting is the slotting process. The edge of structural aluminum plate have been successfully cut by using abrasive water jet machining, and the various steels have been cut in different shapes by using this abrasive water jet machining. So in this lecture we have focused on water jet machining and abrasive water jet machining. We have studied these two processes by considering its working principle, equipment setup, process parameter, material remove rate, and their